Kennan and Elliot present the Sliding Filament Project. The neuromuscular junction. The sliding filament action is initiated by a series of reactions at the neuromuscular junction. The release of acetylcholine from the axon terminal allows sodium ions to enter the muscle membrane through ligand-gated ion channels. The influx of sodium ions depolarizes the sarcolemma, resulting in an electrical impulse. The impulse travels the length of the sarcolemma and T-tubules, releasing calcium into the sarcoplasmic reticulum. At the neuromuscular junction, acetylcholine is recycled by acetylcholinesterase into acetic acid and choline, which diffuse back into the axon terminal. A sarcomere is one contractile unit of a myofibril. Each sarcomere has a thin actin and thick myosin filament. The length of each myosin filament is the A band. The length between two myosin filaments of neighbor sarcomeres is the I band. The distance between two actin filaments in one sarcomere is the H zone. The Z line separates two sarcomeres in a zigzag pattern. Wrapped around each actin filament is tropomyosin. This filament blocks the myosin head from binding to actin. Troponin also sits on the tropomyosin and serves to move it out of the way in the presence of calcium, enabling the cross bridge to form. The power stroke. When the myosin heads bind to actin, the ADP remains from the previous cycle while a phosphate is removed. The cross bridge is formed between actin and myosin heads. As the units slide past each other in the power stroke, the ADP falls off the myosin head. The gliding motion stops when ATP binds to the myosin head, severing the bonds between the two filaments. ATP then breaks down into ADP and phosphate. The myosin heads then return to their initial state. This movement, repeated, causes a muscle contraction. Contraction and relaxation. As a sarcomere unit contracts, the I band and H zone shrink in size while the A band remains the same length. The Z line partitions different sarcomeres and is the site for actin attachment.